Hello students, welcome back to the classes. So this is for HS second year mathematics. So initially I had started with the chapter on matrices, and because of the TDC examination it was discontinued. So let me continue from there. We will begin our offline classes next week. So before we begin, I'd like to ask you to go through this video as a revision. So on the chapter on matrices, so in singular form it's called matrix. Okay, so what is a matrix? All of us have seen table, right? Say the table of say date, okay, say a name, okay, some say the tables that you see in school, right? Your attendance, okay. So some date is given, your name is given, okay, A B C D, okay, your roll number is given, okay. So this type of tabular arrangement, okay, is actually a matrix, right? So mathematically we can say it's a rectangular arrangement of rectangular or tabular arrangement of numbers or symbols, right? In say that's okay. Rectangular arrangement of numbers or symbols. For example, say this one: 1, 2, 3, okay, 7, 8, 9. Okay, this is a matrix, right? This is a matrix. So this is called the first row. Okay, first row of the matrix, and this is called the second row, right? So how many rows are there? There are 2 rows in this matrix. Okay, so we denote this by uppercase letters. It's not mandatory, you may denote it by smaller case letter also, but usually it's a convention. We denote it by uppercase letters and enclosed within parentheses or your brackets. Okay, you can write the same matrix as this also: 1, 2, 3, 7, 8, 9. Okay, but once you fix a particular symbol, please stick to that. Do not change, right? So do not mix up the symbols. If you are writing a matrix with parentheses, that is first bracket, you continue with that. If you are writing with square brackets, you continue with that. Okay, do not change, right? Okay. So this is the first row, and these are the columns. Okay, so this is first column, right? This is first column. This is the second column. This is the third column. Okay, so this is a matrix which contains 2 rows and 3 columns, right? 2 rows and 3 columns. So what will be this element denoted by? Okay, this is the element in the first row and first column, right? This element 1, it is the element in the first row, first column. So we denote this element by A11. Okay, A11, right? So 11 means the first index means row, the second index is the index for the column. Okay, so this is how we denote matrices. The entries of the matrix. These are the entries of the matrix or elements of the matrix. Okay, what will be this element denoted by? This will be denoted by A12, first row, second column, right? 3, this will be denoted by first row, third column. Okay, 7, it will be denoted by first row, seventh column. Second row, first column. So second row, first column, A21. Okay. Then this 8 is an element of the second row in the second column. Okay, so it's A22, right? And 9, it is an element in the second row, third column. So it's denoted by A23. Okay, so that is how we denote the entries of a matrix. Okay, if the entries are not known explicitly, so in general we can write it as this. Okay, clear? So let us see some more examples. So as you watch this video, right, this is not a movie. You watch this video with your pen and paper, okay, copy, right, and you make notes as per the lecture given in the video, okay. So don't just watch it. Mathematics is such a subject. The only way to learn mathematics is to do mathematics, okay. So whatever I am saying here, you please try to note down those things and compare with your books and all. Don't just watch this video, okay, right. So you have to do the mathematics yourself, okay. Say for example some other examples of matrices, some more examples, okay. So say I denote something like, say B, let me take it, this is X, this is 1, this is 2, this is Y, this is say 3, and this is say Z, okay. So this is also a matrix, right. It's a matrix whose first row is x1, second row is x2, 2y, and third row is 3z, okay. So it's a matrix having 3 rows and 2 columns, okay. So we denote this matrix, the order of this matrix as 3 by 2, okay. There are 3 rows. The first index here will mean row, number of rows, okay, number of rows, and the second index here it will mean the number of columns, okay, it means the number of columns, right, as you can see. So a matrix of having 3 rows and 2 columns is said to be of order 3 by 2, okay, 3 by 2, right. A matrix of say having say 3 rows and say 5 columns, okay, 1 2 3 4 5, okay, this will be a matrix of order 3 by 5, okay. This is a matrix of order 3 by 5, okay, clear. So the order of the matrix is nothing but it gives us an information about the number of rows and columns of that particular matrix, okay. So if a matrix is of order 3 by 5, it will mean that it has 3 rows and 5 columns, okay, clear. So this is another example. Now let us see. So in general these are rectangular matrices, okay, and we have a particular thing which is called square matrix. What is a square matrix? Square matrix. So a matrix which has or that has equal number of rows and columns, okay. Matrix that has equal number of rows and columns, okay, is called a square matrix, okay. So please write it down properly. I have just given the hint, okay. So a matrix that has equal number of rows and columns will be called a square matrix, okay. So for example say A equal to say 1 2 minus 1 0 0 3, okay. It may happen that all elements are also 0, okay, that may also happen. So it's a matrix of order 3 by 3, or we say that it is a square matrix of order 3, okay. If it is a square matrix, it has equal number of rows and columns. So if you just mention that it is a square matrix of order 3, so it is sufficient to understand that it's a square, the number of rows and columns is equal to 3, okay. So in case of square matrix, we just say it's a square matrix of order say 3 4 5 6 n, okay, like that, clear. So square matrix. So in general we denote a matrix by, in general we denote a matrix with m rows and n columns as say A equal to Aij M by N. Okay. This is the general way of representing matrix, right? A equal to Aij M by N. What is this I? I is the index of the row, J is the index of the column. Okay, right? And M is the order of the number of rows, and N is the number of columns. Okay, so Aij M by N. This is the general form of representing the matrix. Okay, every time it's not possible to write the matrix in the whole form. Okay, because there are matrix of order 100 by 100 also. Okay, lots of matrices are there. Matrices may be of any order. So we need to develop a symbol to express the matrix. Okay. So this is the one. So suppose I have a matrix, say B equal to Bij, say 2 by 4. Okay. So how will you write this matrix? Okay, you try to write it. You try to write this matrix B equal to Bij 2 by 4. Okay, how do I write this matrix? Okay, we will write this matrix as B, first row, first column. So there are 2 rows and 4 columns. Okay, 2 rows and 4 columns are there. So the element of the first row, first column will be B11. Of the first row, second column will be B12. Okay, of the first row, third column will be B13. There are 4 columns, so the first row, 4th column will be B12. Okay. Then similarly, this will be B21. This will be B22. Okay. Then this will be B23. This will be B24. Okay. This is how we write this particular matrix. Okay. So there are 2 rows and 4 columns. Okay. So it's a matrix of order. It's a matrix of order 2 by 4. Okay. Right. Okay. Now we come to some other types of matrices which I have already discussed. Just go through this. What is a null matrix? A null matrix. So a matrix whose say a matrix say Aij M by N is said to be a null matrix. Said to be a null matrix. Null matrix. If Aij equal to 0 for all I comma j. Okay. If every entry of the matrix is 0, right, then it is called a null matrix, right? So a null matrix of order n by n, Aij m by n will be such that Aij, that is this general element, Aij is 0 for all ij. Okay. So you can write it in more detail for all I equal to 1, 2 up to m. Okay, that means the row indices go from 1 to up to m. Okay, there are m rows, right? So the indices of the row will go from 1 to up to m, and j equal to 1 to up to n. Okay, so this is the better way of writing mathematically. A null matrix of order m by n, okay, is such that Aij equal to 0 for all I and j. Okay. So for example, you can see. For example, we have say A 2 3 or say we denote it by it is denoted by O m by n. Okay, so it's a null matrix O m by n, right? So for example, O. So it's not necessary that you should write it O. You can also write this as A. Or ultimately, the thing is that you should understand the context. Okay, so there is a general convention. We write it as O, okay, so that it's easy to understand that it's a null matrix. So null matrix of order 2 by 3 will be the matrix whose all elements are 0 and having this is the limitation. Yeah. So whose elements are 0 and having 2 rows and 3 columns. Okay, having 2 rows and 3 columns. Right. So let us see another example. Now matrix of order 4 by 1. So there are 4 rows and 1 column. Okay. So this is the null matrix of order 4 by 1. Right. Null matrix of order 4 by 1. Clear? Next you have diagonal matrix. Okay, what is it? Diagonal matrix. Okay. So what do you mean by diagonal? If you just recall your geometry classes in school. So suppose this is a square, right? And you draw, you connect the opposite vertices. Okay. So this is a diagonal, right? This is for the diagonal. So since matrix is a rectangular arrangement, so if I write a matrix here, say A11, A12, A13, okay, A21, A22, A23, okay, A31, A32, A33, okay. So easily you can understand what are the diagonal elements of this particular matrix. A11, this is a diagonal element, this is also a diagonal element, this is also a diagonal element, okay. So there are 3 diagonal elements in the square matrix of order 3. Okay. If it is not a square matrix, then we cannot find out the diagonal elements. Okay. I mean, so we cannot relate it with the diagonals, right? Because if you see 2, 4, 3, 4. Okay. So if you draw something like this here, it's crossing the elements. Okay. So it's difficult. So here you can see, if you observe, for the diagonal elements the indices are equal. Okay. For the diagonal elements the indices are equal. I equal to j. Okay. So it's 1 1, 2 2, 3 3. So element of the first row first column, second row second column, third row third column. These are the diagonal elements. Okay. So what is the diagonal matrix? Diagonal matrix will have only these diagonal elements and all other elements will be 0. Okay. The diagonal elements can also be 0, but all other elements are necessarily 0. They have to be 0. Okay. This type of matrix is called a diagonal matrix. Okay. So matrix, so let us denote it by D equal to Dij n by n. Okay. Square matrix. Okay. This has to be a square matrix. A square matrix D equal to Dij n by n is said to be diagonal. Said to be diagonal matrix. Diagonal matrix if the elements Dij is equal to 0 for all or whenever I not equal to j. Okay. Whenever the row index and column index are different, the entry has to be 0. Okay, that is the thing. Whenever the row index and column index are different, that particular entry has to be 0. Okay. So a square matrix D equal to Dij n by n is said to be diagonal matrix if Dij equal to 0 whenever I not equal to j. Okay. That is the thing. Whenever I is not equal to j, the entry has to be 0. Okay. So for example, say D equal to say 1, 2, 3. Okay. Other entries are 0, right? So this is a diagonal matrix. Okay. Say another one. Say let me write it as E equal to say -1, 0, 0, 0. So let me write a 4 by 4 diagonal matrix, right? 4 by 4 diagonal matrix. 0, 0, 0, 0. Okay. 0, 0, 2, 5, 0. 0, 0, 0, -7. Okay. So this is also a diagonal matrix. See, what are the diagonal elements? These are the diagonal elements. Here, these are the diagonal elements. Okay. So this is also called principal diagonal. Right? Principal diagonal. Okay. Right. So we don't consider this one, right? We consider this one because if you consider this way, the indices will be different. First row, fourth column. Okay. So that is why this particular diagonal has got a special importance here, right? Yeah. So a diagonal matrix is a square matrix whose diagonal elements is off diagonal elements. So these elements are called off diagonal elements. Okay, these are called off diagonal elements, right? Off diagonal elements. So a square matrix whose off diagonal elements are 0 is said to be a diagonal matrix. Okay. Okay. And then I had also done identity matrix. With that I had stopped. So just you go through this particular video so that it will be easier for you to understand in the next class, right? And because of this coronavirus pandemic, the situation isn't normal till now, so we will continue with the offline as well as online mode of classes. So I'll be uploading video lectures in your Google Classroom. Okay, if you have not joined the Google Classroom, please join. Send me a mail. Okay, if you are a registered student of GC College, okay. So eclasses@gccollege.in. Okay. So we have already sent mail as per the admission data that is available to us from the college office. We have already sent mail to all the students. So, but there are some mistakes in the email addresses. So we could not reach everybody. So you can always inform your friends who are in GC College to contact us, right? Okay. So what is an identity matrix? Identity matrix is a square matrix. Aij n by n. Okay. There are n rows and column. Is said to be identity matrix. Said to be the identity matrix. Identity matrix of order n if Aij, so all diagonal elements are 1, okay, and off diagonal elements are 0. Okay, so it's a diagonal matrix whose all diagonal elements are equal to 1. Okay, right? Just let me pull up this. Aij n by n. Okay, so this is the square matrix Aij n by n is said to be the identity matrix of order n if Aij is 1 if I not equal to j, I equal to j, and 0 if I not equal to j. Right? So how will you write this? So it is denoted by in. Right? It is denoted by in. Okay. So what is in? Say what is I2? I2 is 1 0 0 1. Okay, this is the identity matrix of order 2. I3 identity matrix of order 3 1 0 0 0 1 0 0 0 1. This is the identity matrix of order 3. I4 this is the identity matrix of order 4 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Okay, this is the identity matrix of order 4. Okay, that's it. So in general, identity matrix of order n is denoted by in. Okay, so there are n rows, n columns, and the diagonal entries are all equal to 1. Off diagonal entries are 0. Okay. So we had done up to this. So in the next lecture, we will be continuing. Right. So please go through the video and you make notes yourself so that it's easier for you to understand. Don't just watch the video. Right. Thank you.